Hello Year 10, I'm Mrs Newman and this is your first lockdown lesson and we'll be looking at the area of 2D shapes. I've included a checklist so that you can go through and tick when you've completed each task. The first lesson is to watch this video and to follow the worksheet that goes with it. Lesson 2 would be to complete the second worksheet, which is called Part 2 Questions. And the third task, and only when you've completed tasks 1 and 2, is to do the Maths Watch tasks that are set online. Here are your Do Now questions. You can press pause by clicking on this box, and when you're ready, you can restart for the answers. Okay, so here are the answers. 8 times 9 is 72. 12 times 7 is 84. 38 times 4 is 152. Remember, you can multiply by 4 by doubling and then doubling again. For D, E and F, you can use the half at any time. On D, I'm going to use half times 6, which is 3, and multiply that by 5 to give me an answer of 15. For E, I'm going to do half times 20, which is 10, and times that by 9, which is 90. And for F, I'm going to do 5 times 3, which is 15, and then multiply that by a half to give 7.5. For the shapes, the first one's a rhombus. It has 4 pairs of equal sides. The second shape is trapezium with 1 pair of parallel sides. The third shape is a parallelogram with 2 pairs of parallel sides. And the last one is a rectangle. Okay, so let's look at how to find the area of 2D shapes. Well, area is the space inside a shape. For a rectangle, we could count the squares, or we could use the formula area is equal to the length times the width. Using the formula is especially useful when we're given a rectangle with non-integer sides. Can you remember how to find the area of a parallelogram? Well, it's very similar to a rectangle, because if we look at a parallelogram, we can slice a triangle off one end and that would fit perfectly on the other end to form a rectangle. So using the principle of a rectangle being area is length times width, we can use that for a parallelogram, where the length is called the base and the width is called the perpendicular height. Now the perpendicular height is that up and down height, is at right angles with the base. So the area of a parallelogram is base multiplied by the perpendicular height. A triangle is half a parallelogram. So if we know that the area of a parallelogram is base times perpendicular height, a triangle would be half times base times perpendicular height. Another way of writing this is the area is equal to base times perpendicular height, and then you divide that by 2. These formulas are really important. So what you need to do is pause this video and copy these 3 formulas into your books, because you'll need them for the questions later on. Okay, so you can also use the formula if you know the area to find missing sides. In these questions, we need to find the heights, and we're told that both shapes have an area of 12 centimetres. Let's have a look at the parallelogram. Well, the area of the parallelogram is base times perpendicular height, and in this case we know it's equal to 12. So 5 times the height is 12, and when we rearrange that, we can then divide by 5 to give us 2.4 centimetres. In the same way, we can use the area of a triangle, and we know that the area is 12, and using the formula of half times base times perpendicular height, I can do half times 8, which is 4, so 4 times the height is 12, and when we rearrange that by dividing by 4, this gives a height of 3. In this example, we're giving a trapezium. Now the area of a trapezium is half a plus b times h. What do you think the values of A, B and H are? Well, in this example, A is 6, B is 16 and H is 7. H is the height of the triangle. The A and B, it doesn't matter which way round you write them, but the height is very important. This trapezium is on its side. If I turn it the other way round, you can see that the height is 7. So using the formula, I need to do half of A plus B and multiply that by the height. Well, 6 plus 16 is 22. Half of 22 is 11, and 11 times 7 is 77 centimetres. Have a go at questions 1 to 3 on the worksheet. Okay, let's have a look at some more examples. Well, for this question, I've been given a compound shape, and compound shapes are made up of more than one shape. In this example, I've been given a rectangle with a triangle on top, so I'm going to find the areas separately. The first thing I do is to label my shapes A and B. So A would be a rectangle, which is 12 times 3, which is 36 metres squared. And B is a triangle. Now, I don't know the height of my triangle. I know the overall height of my shape is 5, and I know the height of that rectangle is 3. So if I take 3 away from 5, that will give me the height of my triangle. So the height is 2. So a triangle is half times the base, which is 12, times the height, which I now know is 2. And half of 12 is 6, and 6 times 2 is 12. So my total shape would be the 36 metres plus the 12 metres squared, which gives me a total area of 48 metres squared. Okay, here's another example, and this time the shape is made up of 2 rectangles, but there's a number of ways I can go about it. So I could split my shape across the top like this, and I have my first rectangle, rectangle A, which is 15 times 8, and rectangle B. Now, I don't know the height of that rectangle, but I do know the overall height of the shape, and I know that A has a height of 8, so if I take those away, I can see that the shape B would have a height of 6, so 6 times 6 is 36, and I would add those two answers together. Another way I could do it was to split the shape downwards, and I can see that my first rectangle would be 14 times 6, that's quite easy to see. And for B again, I would have to find that missing length. So in this case, I need to do 15 take away 6, which is 9. And so I would then do 9 times 8, which is 72, and add those answers together. Now this is the same question again, but this time I'm going to look at it as one big rectangle. So if I look at this shape and I can see that I've got a pink shape and a white rectangle, if I was to find the area of the large shape, that's 14 times 15, I could then take the white rectangle away from that answer. So that white rectangle would have a base of 9 and a height of 6. So I would take 9 times 6 away from 15 times 14, and I would get the same answer. Okay, so there's one other formula we need to look at, and that's the formula for an area of a circle. And some people get confused because area of a circle and circumference of a circle are quite similar in formulae. So A is, this says the area is pi times diameter. Well, that's not correct because that would be the circumference. B is 2 pi times the radius. Well, actually, that's the same as multiplying by the diameter because 2 radii equals the diameter, so it's not that one. The correct answer would be C. The area of a circle is pi r squared, so it's pi times the radius squared. Remember that radius is the line that goes from centre to rim on a circle. Now I can use the formula for finding the area of a full circle to find the area of a semicircle. So I know the area of a full circle is pi times the radius squared. Now we haven't been given the radius, we've been given the diameter. So I just need to halve that 16, which is 8, and pi times 8 squared is 64 pi. So what I've done is I've left this in terms of pi. That means I'm not using a calculator. So I know that 8 squared is 64, and 64 times pi, we just write that as 64 with the pi symbol next to it. So the area of the semicircle would be half that answer. So semicircle would be 64 pi divided by 2, which is 32 pi centimetres squared. And that's my answer. We call that in terms of pi. That's a non-calculator version. If I was using a calculator, I would put that into a calculator and write 32 multiplied by pi, and then it would tell me what the full answer is. But this is just in terms of pi. Now have a go at the rest of the worksheet.